In this video, we're going to be talking about permutations and combinations, just some quick introduction and ways that we can use a formula to count the number of different ways that we can organize groups of objects. So the first thing we can talk about is combinations. Combinations is a group of objects or the number of groups of objects where we don't care about the order. So we can repeat things in our groups or not. It just depends. Combinations, they don't care. It's just how many different ways can we organize the amount of objects in our group where we don't care about the order. So there is a formula. It's a little hard to see in the video here, but hopefully you've downloaded the notes and it's much clearer. I also rewrote it. It's just written in a slightly different order, and I'll talk about why I prefer to reorder it sometimes. Essentially, though, our equation is asking for two different things. It's asking us to think about how many total objects are in our big overall sample group, and then also asking us to think about how many different ways are we trying to put them into a group. How many are we taking them 5 at a time or 6 at a time? So this R is the number of spots we want to fill in our group. That's one way I like to think about it. So the total number of things in our group and the number of spots you want to fill, or how you want to order those groups. So for example, we're going to a restaurant and they allow us to choose from 8 different appetizers, and we're going to order an appetizer sampler plate, which allows us to choose any 5 of those 8 appetizers. So out of a total of 8 different appetizers, we want to group them into groups of 5 or take them 5 at a time. And let's see how many different combinations we can come up with for this appetizer sampler. So using our formula, taking 8 appetizers 5 at a time is going to be 8 factorial. And then on the bottom, we're going to have 8 minus 5 factorial multiplied by 5 factorial. So a factorial is going to make us multiply this number by all of the numbers underneath it, all of the whole numbers. So 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. On the bottom, when we simplify, we got 8 minus 5 factorial. That's going to be 3 factorial. And we're going to have this additional 5 factorial in there as well. Be careful, don't multiply these things together. It's not 15 factorial. Let's just treat them separate. We're going to cancel some like factors or common factors that are on top being divided by the bottom. If it's 8 factorial, then we're multiplying 8 by everything underneath it. 5 factorial would be similar in that it's 5 times everything underneath that. We'll notice that we have some similar factors here from 5 below. So we're going to end up canceling 5 factorial on top and bottom, leaving behind 8 times 7 times 6 on the top, and 3 factorial, which was left over from the bottom, 3 times 2 times 1. So on top, multiplying those 3 numbers, we get 336. And on the bottom, multiplying those 3 numbers, we get 6. Divide it, and we get 56 different ways we could order this appetizer. So make sure you bring 55 other friends, and you could sample each of them. One more time, a similar example. This time we're going to be choosing between 14 different roller coasters, and we're going to choose them 3 at a time. How many different ways can we ride 3 of them? So again, 14 is our total. We're putting them into a set of 3 or choosing 3 at a time. So we're going to take 14 factorial and multiply that all on top, 14 by everything underneath it, write it out. You usually want to do that until you understand what a factorial is, and then we can start to play these other games or these other tricks that I'm showing you as well. 14 minus 3 to simplify is going to be 11 factorial. So if we have 14 times 13 times 12 times 11 and everything underneath it, then that 11 factorial on top is going to be canceled by the 11 factorial on the bottom, leaving behind just 14 times 13 times 12 on top and the 3 factorial on the bottom, 3 times 2 times 1. So again, looking at that visual right here, it's a little cut off, but I know that 11 times everything underneath it is going to be on top as well as on the bottom, so we're canceling the 11 factorial, leaving behind that 14 times 13 times 12 on top and the 3 factorial on the bottom, or 3 times 2 times 1 on the bottom. Multiply your top numbers, we get 2,184, and on the bottom we get 6. So divide that, and we get 364 different ways that we could ride 3 roller coasters at a time out of a total of 14 choices. All right, next let's talk about permutations and how they're different. A permutation is similar in that it's the number of ways in which we can organize a group, but this time our order is going to be important. We're going to care how we order them. We don't want to repeat things, for example. Oh, and just to throw in a little fancy factorial property. Factorial, as we just talked about, is numbers that are multiplied by themselves and every whole number below them. But then there's this special case. What is 0 factorial? And 0 factorial is defined as being 1. So that's kind of a weird one, but that's its property right there. So again, we got a formula to find permutations. We're going to do the exact same thing where we find the total number in our group and take an r at a time, or the number of spots we're trying to fill with that amount of things. So still trying to analyze or figure out 2 of those things in our problems, and then plug them into our formula. I think permutations are a little bit easier than combinations in that we really don't need a formula if we know how many spots we're trying to fill and we know how many total objects we're trying to put in those spots. But I'll talk about using both ideas here. In this example, we have 8 members in a club, and we're trying to elect 3 positions: a president, a vice president, and a treasurer. So we got 8 total people, and we're trying to put them in 3 spots. So without even using the formula, we could think about this conceptually. I know I'm trying to fill 3 spots. I know that to choose a president, I have 8 different people to choose from. If I've already assigned a president, then I must only have 7 people to choose from for my vice president or treasurer role. And then if I've already elected those 2 positions, then I only have 6 more people to choose from for that last position, such as the treasurer. So we could just do 8 times 7 times 6, and we would get the total number of ways that we could choose those 3 spots from 8 different people. However, in using the formula, we have a way that we can, to solve any permutation, we're going to find our total number of people, 8, and we're putting them into 3 spots. So the formula says to do 8 factorial over 8 minus 3 factorial. So we have 8 factorial over 5 factorial. So we know that everything from 5 below is going to cancel on top and bottom. We could write it out longhand and then cancel our common factors on top and bottom, leaving behind 8 times 7 times 6, which is exactly what we thought of conceptually before we used our formula. And that's given us 336 different ways that we could pick 3 positions given 8 total people to choose from. One more example here. Very similar. We got 13 people on our team, or in our group this time, and we're going to try and put them into 4 different positions: the first base, second base, third base, and shortstop position. So if we're trying to choose 4 at a time from a total of 13 people, then we know that we have what we need to set up our formula: our total factorial over the difference in our total minus the number of ways in which we're putting them. So 13 minus 4 is going to give us 9 factorial on the bottom. We could write it all out, or we could know that from 9 factorial beyond, we're going to cancel on top and bottom. So that just leaves behind 13 times 12 times 11 times 10, or 17,160 different ways that we could arrange players into 4 positions if we're choosing from 13 total players. So there's a couple examples on how to set up and find the number of permutations or combinations, knowing that combinations don't matter about the order and permutations do matter about the order. So I think that's the trickiest part, is determining whether your scenario involves a combination or a permutation. But if you've decided which they are, follow those simple formulas and you can find the total number of ways in which you can group them.